welcome again for continuation. We had started the topic heat transfer, and we had mentioned the modes of heat transfer: conduction for solids, convection for fluids, and in vacuums, radiation. So in this case, I'd like us to remind ourselves something, then we continue to the factors affecting the rate of conduction of heat in different conductors. It is good to note that all the materials do not conduct heat at the same rate, because we have said, first of all, the conduction of heat is due to vibration of particles, which are atoms, to be specific, and also free or mobile electrons, which conduct heat in the structure of a given conductor. There are some materials which are not metallic, but they conduct heat. Such materials rely on vibration of particles alone. They rely on vibration of particles alone because they don't have free electrons or mobile electrons in their structure. So it is only the metals. It is only the metals which conduct heat by both vibrating particles and by the means of free electrons, because metals have both, unlike other conductors which will only have particles vibrating and then they conduct heat. Therefore, it's good to note that it is only metals which conduct heat by both the vibration of particles and the movement of free electrons alongside their structure. Therefore, with that, now we can check the factors affecting the rate of conduction. 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 There are several, but we will study them bit by bit. So the first one is the temperature difference. Temperature difference. The temperature difference. I started by saying that basically heat flows from a material to another one due to temperature difference. Therefore, how does temperature difference affect the rate of conduction? This is it. If you take, for example, you take a iron rod or two iron rods. You take two iron rods, then you place one on a hot flame and the other in boiling water. Then you time them. You wait for some time. You find after a given time t, the one or the rod placed on a flame feels hotter than the one placed in boiling water. You know, boiling water is at around 100 degrees Celsius. The hotter part of the Bunsen burner flame, which is the non-luminous flame, is at around 500 degrees Celsius. So compare, the two rods are initially at the same room temperature. We can say they are at 23. This rod is at 23 degrees Celsius, and another one is also at 23 degrees Celsius. They are at the same temperature, the same length, the same radius, the same material. Now, the difference is now the flames or the environments where you place them. So you have the first one on a flame, which is non-luminous, the hottest flame, and the other one, you just dip it. You just dip it in boiling water. You just hold it inside boiling water. So you realize after some time this one feels hotter than this one, because the hot flame is at 500 degrees Celsius, the boiling water only 100 degrees Celsius. Therefore, there is a big temperature difference between this rod and the flame compared to the difference here in the temperature between 23 degrees Celsius and 100. Therefore, this temperature difference is very big. And you will find that because of the high temperature difference, then there will be a higher rate of conduction compared to the other case where the temperature difference is low. So we can see that the higher the temperature difference, the higher the temperature difference, the higher the rate of conduction. The higher the rate of conduction, the higher the temperature difference, the higher the rate of conduction. Let me explain this one. We had earlier on said that conduction is due to electrons or vibration of particles. Vibration of particles. Vibration of particles. Therefore, we say that when the temperature difference is high, when the temperature difference is very high, you'll find that the particles in the conductor, the conductor is the material which conducts heat from one point to the other without the conductor itself moving. It's good to note this. During conduction, it is heat which flows within the conductor, but the conductor remains intact. It doesn't move. It is only the heat which is conducted through heat. Therefore, now you find that the particles in the conductor increase in kinetic energy faster, making them move faster, and within a short time they transmit energy or heat energy to the neighboring particles, So you find within a short time, because there is a high temperature difference, then there will be a great rate of heat from the high temperature body. Let's say this is the flame at 500, and this is a that rod at 23. Therefore, the net flow of it will be faster here because it will be from a very high point going to a lower point compared to when it's just flowing from 100 degrees Celsius to 23. The concentration difference here is just 70 something, but here it is 400 plus and 77, I think. Yeah. So you find now, because of the great difference, heat will flow very fast. It will flow very fast. And now, by heat reaching one point of the conductor very fast, it means the particles here will gain high kinetic energy, vibrate faster, affecting the neighboring particles, and the heat is conducted by such means. Or the ions, not ions, the electrons, the free electrons or the mobile electrons at this point, they gain kinetic energy very fast, and the high kinetic, because they are mobile, they move to the other parts, transmitting the energy to other electrons in the same structure, and such heat will be conducted to the other parts of the conductor. Therefore, we say that under this factor which affects the conduction of a given conductor, the higher the temperature difference, then the faster the rate of heat transfer. So that is how the factor affects conduction of heat. In the next, I'll be dealing with how the length of a conductor affects conduction of the given material. So thank you very much for following.